Alright, our third lesson in this unit is linear equations. So we're going to be solving some linear equations.
Write and graph the equation of a line.
Here's our vocabulary. You should have already seen it before from our Algebra 1 review videos. If you didn't get it down, you got a second chance to get it down. So pause the video if you need to get this information down because we'll be using it. Alright, second page of vocabulary, and it's our three formats that we're going to see our linear equations in: slope-intercept form, point-slope form, and standard form. And you need to be familiar with all three, so pause if you need to and restart when you're ready. Alright, here's our slope formula, so you need to write the slope formula down. You're going to need to have it handy whenever you're doing any of these problems. So pause if you need to and write this slope formula down. It's very important. Alright, here's 4 examples of using the slope formula. We've already done the slope in the review videos. So what I want you to do is I want you to, and let's see, I've got an extra parentheses there. I want you to go through and find the slope through the points, and when you finish, restart the video, check your answers, and we'll talk about a thing or two then. So see if you can find the slope for all 4 of these. Alright, here are my 4 slopes. If you'll notice in the first one, I got a positive slope. That's one type of slope you can get, a positive slope. I got a negative slope. That is a second type of slope you can have, positive and negative. You can also have a zero slope, and I'm always going to get a zero slope when my y-coordinates are the same. And finally, I have an undefined slope. It's because my denominator is 0. You can't divide by 0, so that makes the slope undefined. And if you'll notice with the ordered pairs, my x-coordinates were the same. If your x-coordinates are the same, you're always going to get an undefined slope. And this leads us into the next slide. Basically, when you have a slope of a line, this is the type of lines you get when you have a positive slope. Your line is going to rise to the right. When you get a negative slope, it's going to fall to the right. And whenever you have a zero slope, it is a horizontal line. And an undefined slope means you have a vertical line. And if you know these 4 pieces of information, it can help you a lot when you take the ACT. So you might want to write this down. So pause if you need to write it down. Alright, now in example 2, what we're going to do is we're going to use things that we already know to write the equation of a line that passes through the points 2, -2 and 3, 2. And the first thing we're going to do is find the slope. To find the slope, we're going to use the slope formula. And if I label my points here, my x1, y1, and my x2, oops, that's supposed to be y1, my y1, and that's supposed to be y2. So here my slope is going to be y2 minus y1 over x2 minus x1. And remember that minus minus makes it a big O plus. So it's really going to be 2 plus 2, which is 4, over 3 minus 2, which is 1. So my slope is 4. Alright, now that I found my slope to be 4, I'm going to take that information and I'm going to plug the slope and one of the ordered pairs into the point slope formula. Alright, so here is the permanent parts of the point slope formula. I always have the y minus, the equals, and the x minus in parentheses, and all I have to do is substitute my other information in. And since I labeled this one x1, y1, I'm going to use that point when I plug it in the formula. So y minus y1, which is a -2, equals my m, which is always my slope, 4, minus x minus my x1. And I'm going to simplify this a little bit. Remember, my minus minus is a big old plus, so my formula ends up being y plus 2 equals 4 times x minus 2. And that's my equation in point slope form. Now I'm going to take my equation that I got in point slope form and I'm going to put it in slope intercept form. Slope intercept form, if you'll remember, is your y equals mx plus b. So basically, I need my y by itself. So first of all, I'm going to use my order of operations to simplify this and get y by itself. So the first thing I'm going to do is I need to get rid of my parentheses. So I still have my y plus 2 over here, and I'm going to distribute the 4. I'm going to multiply it by the x. That gives me 4x. And I'm going to distribute my 4 to the negative 2. That means I'm going to take 4 and I'm going to multiply it by negative 2, and that gives me a negative 8. Alright, now for it to be in slope-intercept form, that y has to be by itself. So I have to get rid of that addition of 2. And I'm going to subtract 2 from the 8. I'm doing it from the 8 because they're both plain old numbers. I cannot subtract 2 from the 4x because that 4 has an x attached to it. And 4x and negative 2 are not like terms. So here is what my equation looks like in slope-intercept form. And finally, the last thing I have to do with this example is I have to graph it, and that's why I put it in slope-intercept form, because it's my format for building a graph. So first of all, my slope-intercept form is y equals mx plus b. My b is my y-intercept. The vertical is my y-axis. I'm going to use that point. And let's see, 1, 2, 3, 4, 5, 6, 7. So 8 would be about right here. So that's my starting point for my graph, my y-intercept. That's the only time I use that y-intercept, and then I move over to the slope. My slope here is 4. And I can take 4 and make it a fraction by writing it 4 over 1, because 4 over 1 is still 4. So what I do is I count off from my starting point, my y-intercept. I rise up 4, 1, 2, 3, 4, and I go over 1, and that gives me another point. And then from that point, I can use my slope over and over again. I go up 1, 2, 3, 4, and over 1. And up 4, 1, 2, 3, 4, and over 1. And if I connect my dots, here is my line. Okay, here's something I want you to try, or I want you to think about it. Does it really matter which of those ordered pairs in that example we used when we substitute in our point slope form? I want you to use the second order pair for your x1 and y1 and plug it into the point slope form and see what happens, and we'll talk about it in class. Alright, example 3. I have an equation here that's in standard form, and I know it's in standard form because I have my x and my y on one side and my plain old number on the other. As long as my x and y are with each other on one side, it does not matter which side it is, and my plain old number's on the other side, it's in standard form. Alright, to move from standard form to slope-intercept form to graph it, what I have to do is I have to take the x over here. I'm doing that it's a positive x by subtracting it. Or when the x crosses the bridge, it changes sign. So then I end up with negative x plus 6. And then finally, I have 2y here. Remember, when I have a number in front of a variable, it means multiplication. And then to undo multiplication, I divide. Now here's a thing where most people are going to encounter problems. Once I divide by the 2 here, I had to divide every term on the other side by 2 also. That's the most common mistake people make, forgetting to divide every term when they divide through like that. So I have negative 1/2 x plus 3. That's my equation in slope-intercept form. Alright, I want it in slope-intercept form because it's my blueprint for creating a graph. So I'm going to start at my y-intercept. This is my y-axis. So I'm starting at 1, 2, 3 on the y-axis, and then after I do my starting point, I use my slope. A negative in front of the 1 means instead of rising up, I fall down 1, and then I run to the right 2. So here's another point. And I can use my slope again. I fall down 1 and I run over 2. I fall down 1 and I run over 2. And if I connect the dots, this is the graph of my line. So now you've graphed a linear equation that's in standard form. Alright, so next we're going to take another equation, and it is also in standard form here because my x's and y's are on one side and my numbers on the other. And we're going to graph it, but this time we're going to use the x and y intercept. Alright, we've already done this, so this is just a little review. I'm going to start with finding my x-intercept. And to find my x-intercept, that means I set my other variable, y equal to 0, because the ordered pair of an x-intercept has a y-coordinate of 0. So when I substitute that in, I replace the y with 0. And what happens is that cancels out, and I get negative x equals 6. And since I'm solving for x, I want just a plain old x, not a negative x. So, and I know that's a 1 in front of that x, so I'm going to divide by negative 1. So my x-intercept is negative 6. And I'm going to, on the x-axis, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm going to plot my x-intercept. Now I'm going to go ahead and find my y-intercept. To find my y-intercept, I set my x equal to 0 because the ordered pair for a y-intercept has an x-coordinate of 0. So I substitute in 0 for x plus 3y equals 2. And then I have just 3y. Oops, I'm sorry, that is a 6. 3y equals 6. I skipped ahead to the answer. Alright, and I'll keep trying to write the answer down there. Y equals 2 is my y-intercept. So I'm going to plot that right there on the y-axis. Y equals 2. And now when let me do it with black, when I connect the dots, I have the graph of that line using the x and y intercept. Alright, let's see what you've learned. See if you can go through these 4 equations, linear equations, and tell me what format they're in. Slope-intercept, point-slope, or standard form. So see what you come up with, and we'll discuss it in class.